Welcome, everybody. Thanks for joining us to discuss enterprise job scheduling and how you can cure the headaches of native schedulers. Looks like the number of people joining has slowed down a little bit, so let's get started. I'm Rob Newman, Solutions Engineer for Help Systems, and I specialize in workload automation. Today, we're going to talk a bit about some native schedulers, some of their pitfalls and shortcomings. And since native schedulers just aren't meant to be cross-platform or enterprise-wide, we're going to dig a little deeper into exactly what an enterprise job scheduler is. And we're not going to just talk about why you want an enterprise scheduler, why you want JAMS. I'm going to show you. There will be a Q&A session at the end, so please add your questions to the question box and I will be happy to address them. All right, let's start out with a poll question. What native schedulers are you currently using? Windows Task Scheduler, SQL Server Agent, cron, a mix of different OS and application schedulers? You're unsure. Wow, the answers are coming in fast and furious. I'm guessing most of you are using more than one. All right, it looks like the responses have slowed down a little bit. And just as I figured, most of you are using a mix of operating system schedulers. Easy to orchestrate. Let's take a moment to talk about some of those native schedulers. Tools like Windows Task Scheduler, SQL Server Agent, and cron. Did you know that Windows Task Scheduler assigns a process priority of below normal to all tasks? Talk about not taking your job seriously. SQL Server Agent relies on praying that your job finishes in time and requires a level of faith beyond mere mortals. And cron tabs requires either a degree in cryptology or a cron tab generator to decipher. Yes, they do come standard with Windows, SQL, and Unix. Yes, they can handle basic automated tasks like backups, running scripts and executables, and simple, specific time-based executions, etc. They are the perfect tools for scenarios where you only have a few users who set the schedule or troubleshoot issues, where jobs run predictably with the same runtime and the same resources and rarely error, where your jobs are atomic. They run on one system and don't depend upon sub-processes, where your job definitions rarely change. They're stable. And where everyone knows what the jobs do. We call these happy path jobs, jobs that are using pillow scheduling. But what happens when you become a team of 10 people scheduling thousands of jobs? And then what happens when a few of those people on that team leave? Suddenly you're not dealing with little tasks and potentially little problems. You're dealing with a whole ecosystem. Here are some of the most common shortcomings we hear when it comes to native schedulers. Running individual tasks might work well, but when you have to maintain separate job schedulers across separate servers, it becomes more challenging. Doing this requires you to log into each server to view or schedule tasks, and that's time consuming. It increases the likelihood of error. Individually managing each scheduler impedes you from creating a well-orchestrated and well-automated environment. Even more so, as your business grows, you will likely need to add more servers and create a more diverse environment. So it's essential to take a long-term view for your scheduling your tasks that will coexist in a hybrid or mixed server infrastructure. Native schedulers work well as long as the schedule applied to a job is straightforward. In Task Scheduler, for example, you can define a single job to run daily, weekly, or monthly. These settings work for simple tasks that need to be repeated on predictable schedules. But as scheduling requirements grow more advanced, there are no viable options. When it comes to scheduling based on dependencies, these schedulers do not account for variability or potential failure. For example, imagine you're scheduling a series of 3 tasks required to run one after the other. In Task Scheduler, you'd be required to schedule the tasks based on how long the previous task takes. But if one task inadvertently fails or takes longer than expected, the job will not complete in the way you were expecting it to. And that may impact the entire outcome of the business process across your whole organization. They also lack connections to custom calendars, such as bank holidays or fiscal periods, calendars that are extremely relevant when automating business processes. You can link jobs together through SQL Server Agent, but you'll rely on that pillow-based scheduling, adding artificial buffers in between steps, which will catch up with you as more jobs are added to the scheduler. Native schedulers also require that developers output script log information to a separate .log or text files that they can pull up and reference as needed. This not only creates a decentralized, disconnected approach, it also makes it extremely difficult to triage failures. Creation of these separate files requires multiple touch points and offers little to no way to centrally manage the outputted files. This causes additional complexity and diminishing returns as your automation initiatives grow across your business. Your native scheduler probably offers some standard reporting capabilities, but it's not really configurable. It makes it difficult to assess the efficiency of scheduled tasks across different functions. For example, you cannot configure SQL Server Agent to send email notifications when tasks have started. You would need to create a PowerShell script or use a third-party application in order to expand the reporting functionality. And what about failed jobs or a file that shows up late? How much time do you spend monitoring and chasing down this information? Needless to say, this arcane language doesn't align well with today's agile team strategies. Only your cron experts can decipher how automation is being applied to a particular business process. Cron syntax is so opaque that a number of third-party websites have been created to help users build valid schedules. And validating those schedules and adding buffer time between steps requires exceptionally complex scripting. If any of those items on these first few slides resonated with you, you're in the right place. Next, let's dive into the basics of an enterprise job scheduler. I'm going to start off here by saying something really obvious. No business exists in a bubble, and no process exists in a bubble. Chances are you have half a dozen applications in use right now, and they just don't talk to each other. And we actually find that's especially true when an application has an internal scheduler like JD Edwards or SAP, because it's easy to set up some simple jobs inside of those applications, even though it may hurt the overall process. There's also a good chance you are running jobs on multiple platforms. Even if you work on Windows and don't touch Unix boxes, processes need to run on each of those systems. And of course, you're generally going to have multiple servers where applications are running. Having everything separated out between applications and people and departments and locations brings a lot of challenges. It's easier for things to get out of hand, or worse, for things to get siloed so that there's no cross communication. Interaction between those silos, whether they're applications or platforms, often becomes manual work. One of the core principles of workload automation software is bringing those things together so that there's one brain, one interface, handling automation for all processes. Another key piece that you should know is what's running, how it's doing for all of the processes in your environment. You should have a single pane of glass where you can see that your Informatica job is 30% of the way through its normal runtime. You should be able to go into workload automation software and see what the schedule is going to look like later today, later next week, or even a month from now. I've lost track of the number of times I've heard something like Visio is being used to illustrate what next week's schedule should look like. So the second key to workload automation software is giving you good information on everything that's running and automatically generating projections for you on what's going to run down the line. The third key is automatic detection of things that could be problematic for you and your business, and the ability to create automatic responses to any of those possible failure points. Let's say you have a backup process that normally takes half an hour and it finishes in 30 seconds and says it was successful. Well, it actually finished without an error. You would know that something is up because there's no way it ran that fast and actually did what it needed to do. So with workload automation, you have a property or a setting that puts you in control to say, if this backup finishes in less than half its normal runtime, let's actually mark this as an error because I know it wasn't really successful. The second part of this concept, the automatic response, is even more exciting. You know that when the backup finishes too fast, it just needs to rerun and it'll finish successfully. Rerunning jobs or taking certain actions with cleanup jobs in response to a failure not only reduces the amount of time you need to spend checking on things, it makes your jobs and the schedule more resilient. You should never have to spend an hour or an afternoon cleaning up because a network blip caused the job to fail. And with workload automation, that job is going to be smart enough to rerun itself so that you don't have to manually respond. Now, I know there's at least one person on this webinar thinking, that's great, but not everything is mathematical. You can't set up paths for everything. Sometimes you need a human response. And you're exactly right. And that brings us to our next key, alerting and auditing. How and when you learn about these unique process events is monumentally important, which is why workload automation solutions come with built-in options for alerting through email, SMS, chat alerts to applications like Slack and Teams, and the ability to hook into third-party tools like SCOM. Along the same lines, if something does fail, workload automation software is going to keep a record of that failure and the job log for you, so you know what happened and when. And that auditing also extends to the processes themselves. If your operators are alerted that an ETL process has failed, they should be able to see that, hey, Joe went in and edited the ETL process earlier today. Let's roll back to a version before his edits. And yes, workload automation does give you all of those tools. The last key is smarter event-based scheduling. Time schedules are great, they work, and we have tons of options for those. But the real key to workload automation is the what, how, and why things run. Chaining jobs together in a process within a centralized scheduler gives you immediate benefit because you know job 2 is going to run until job 1 finishes successfully. No more pillow or pray scheduling where you say job 1 should finish in 20 minutes, so let's schedule job 2 30 minutes out. You can also eliminate the manual file watching by setting a trigger to do it for you and kick off jobs once it sees a file in that folder. So we've talked about some key concepts and features of an enterprise job scheduler provides. There are many more, but ultimately the big question is, what are the benefits of an enterprise job scheduler? Well, it boosts your productivity and reduce costs. It will gain insights into your workflows and allow you to more closely and easily manage your processes. It will give you the flexibility to orchestrate across your whole ecosystem and ensure all dependencies and deadlines are met. Let's take another poll. What features of an enterprise scheduler that you want, and what are the benefits? Lots of answers coming in here. No real surprises here. Looks like you guys want it all. And that's what an enterprise scheduler will give you. All right, we'll close this poll out. Move on. Now that you know that you want an enterprise job scheduler and what the benefits are, let's take a closer look at why you want JAMS. Besides having all the features and benefits you require in an enterprise job scheduler, JAMS sets itself above others in a number of ways. JAMS is code-driven, allowing you to seamlessly work with PowerShell, REST APIs, and .NET, as well as any scripted language out there. If you can script it, JAMS can run it. JAMS centralizes job management across all platforms and applications, all monitored from a single pane of glass. Additionally, JAMS offers dynamic and interactive relationship diagrams, not just for your workflows, but also for your running processes. Lastly, JAMS is continually improving performance and upgrading features, all the while providing the best customer support in the business. All right, how about we take a little peek inside and see what some of this looks like. One key feature of an enterprise job scheduler should be the ability to dynamically view and interact with your running processes. Yes, we have a number of features that will automatically ensure dependencies are met, as well as ways to programmatically handle recovery and retry activities. But sometimes you just need to identify that running job or that failed job in a process. Here we can see what triggered this sequence of jobs. We can see the dependencies and preconditions that allowed this job to run. We can see all of the child tasks that are running in this. Yes, it is interactive. I can release this sequence and let it actually run. We use color coding to determine state, and we can see exactly where in this process is running. This is a sequential top-down processing manner. You can always expand out and explore each of the jobs individually in this view. We can also run jobs in a parallel block. Any job that fails in this will halt the sequence. Hovering over this failed job will actually give you a glimpse into the log for this job. If you need to manually intervene, you can right-click, which will allow you to retry the step, continue on past it, go to the details for this submission, and even edit the job right from here. We can continue on past this error, allow the sequence to continue down to completion, and here we can see any downstream activities, events, recovery jobs, and notification jobs. Now, what about that single pane of glass that we talked about? Well, here you can see all of your jobs across your entire ecosystem. These could be your PowerShell or your SQL jobs, your Linux and your Python scripts. Maybe it's JDE or Informatica. All of your API calls here as well. You can see jobs that are currently running, jobs that are about to be run, jobs that are on hold. Maybe they're pending a prerequisite like another job or waiting for a file. All the job properties and the runtime statistics are available here in this view. And as with the diagram view, you have complete control over your job's executions right from here as well. Take a quick look at a basic sequence in JAMS. Here is the diagram view for the complete configured sequence. We can see everything that triggers this sequence. We can see all of the preconditions that are configured for it, not just the ones that were satisfied, all the child tasks, and all of the downstream activities, notification, and recovery jobs. The JAMS, there is no secret decoder ring needed for setting up schedule triggers. We use natural language date specifications along with exceptions and custom calendars. We make it easy to ensure jobs run exactly when you want it to. You can very easily and intuitively add triggers, dependencies, event handlers, and your notification and recovery options. You've got questions, we've got answers. I see a number of questions have been posted, so let's go take a look. I see John is asking here, what scripting language do you support? Pretty much every scripting language out there. Like I said previously, if you can script it, we can run it. Python, Perl, basically take the native syntax, put it directly into GEMS. And by the way, our audit control system, version it, control it every time you make a change to those jobs and the script within those jobs. All right, let's see what else we've got. We have another question here about how to get your Windows Task Scheduler jobs or your SQL jobs into GEMS. We have converters built in for those. Simply clicking on the shortcuts for Windows Task Scheduler or SQL jobs will pull up a list of those jobs on their respective servers and allow you to convert them in a single page wizard into GEMS. Question here about, can we search the system to find specific jobs? Absolutely. In fact, let me open this up real quick again. Go back to our main client screen. Oops. There it is. Our search box here will allow you to just start typing. It'll pull up the top 5 entries here, or I can show all the results. And this will allow me to search for quite a number of objects, as you see here in the object types, in both the name, the description, and the logon as for all of the properties. So there's a couple questions here that go beyond the scope of what could be answered here. And if I didn't get to your question, I apologize, but please be assured that we will reach out to you so that all of your questions will get addressed. That'll wrap it up for today. So thank you for joining us and have a great day.